Good morning, everyone. My name is Ahmed Hisham. I'm a deep learning engineer in the Artificial Intelligence Technology Center at Must University. I'm going today to propose to you our winning solution for assert applier idea, three-stage deep learning system for COVID-19 awareness, prediction, and diagnosis. This is which is entitled under the name of our paper, Deep Learning Framework for COVID-19 Awareness, Prediction, and Diagnosis. This project was done under the supervision of Professor Rania Gohari, Dean of Artificial Intelligence Technology Center at Mast University. We are going to talk about the problem definition, chatbot system, stands for the awareness stage, the diagnosis stage, which is chest X-ray system, live predictor system, which is a prediction stage, and our deployment. Starting with the problem definition in 2020, February, in Wuhan, WHO announced the appearance of a new worldwide pandemic called novel coronavirus, which is COVID-19. This virus became a very threatening weapon to the whole world, where every country of the world began to its lockdown stage, and a lot of people got infected, and a lot of people got death by the infection of COVID-19. Then the call for using the artificial intelligence and big data analytics was a very crucial call to stop the COVID-19 pandemic. Our first stage was the awareness stage, which is a chatbot system built using Google Dialogflow, which is a cloud-based service for automated-based chatbots. This chatbot contained a lot of intents in the field of COVID-19, where this data was retrieved by or from the WHO. This intent includes the symptoms of COVID-19, how the COVID-19 is spreading in English and Arabic language, the incubation period, the effect of COVID-19 on pregnant. Also, it includes videos of putting face mask or washing hands correctly to avoid the COVID-19. So we call our first stage the awareness stage. Our second stage is the chest X-ray system. The chest X-ray system is contained of two submodules. The first module is chest X-ray checker, where this model is intended to check whether the image input to our model is a chest X-ray or not, which gives better validation and avoid the biasing of the CNNs. The second submodule is the COVID-19 chest X-ray model, where it detects the initial diagnosis of whether this patient is suspected to have COVID-19 or not. Since this model was built in March 2020, where mostly some of the medical domains, or all of the medical domains at this time, was depending on the usage of X-rays to classify the COVID-19. So our model consists of binary classification model. CNN VGG16 architecture, where it classifies whether the patient is suspected to be COVID-19 or not. Our dataset was balanced of 458 chest X-rays for COVID-19 patients provided by the University of Montreal and verified by our domain experts. 458 chest X-rays for healthy people taken from the chest X-ray pneumonia dataset on Kaggle and also verified by our domain experts. The data was divided into 80% for training and 20% for validation and testing. As you can see, the output of our VGG16 CNN classifier was extremely very good in achieving very high results, near 99% accuracy after 14 epochs. We have the second chest X-ray model, where it detects whether the image is a chest X-ray or not, so that we avoid biasing our CNNs. The model was built on a dataset of 6,098 chest X-ray images for COVID-19 patients and combined with healthy chest X-rays, and also the negative class was 3,900 images from scene recognition, so that our model can binary classify whether our input is a chest X-ray or not. As we can see, here is our model input, where it classifies whether the chest X-ray is it a chest X-ray image or not, which totally helps us in our deployment stage. We used also in our deployment Docker and TensorFlow Serve to provide an API for the chest X-ray module, which is the diagnoser. And here is our API architecture. The third module, which is the last stage, is the live predictor, which gives the results of 5 days ahead for every number of COVID-19 suspected or predicted cases in a certain country. It was built by LSTM, long short-term memory, which is an enhancement of recurrent neural networks. Live predictor was inherited from the weather forecasting prediction model, where it inherits some of its features like the downtrend and the uptrend, since the COVID-19 was expected to have an uptrend and downtrend. So we here selected the time series forecasting to follow its trends. Since we are going to use the the time series forecasting, so the best solution for the time series forecasting is obviously the LSTM. We used our LSTM, which is, to be specific, bidirectional LSTM, where here we tested the model on Egypt, as the blue color got the actual cases for 5 days, and the red color got the predicted our predictions that is coming out of the LSTM for 5 days. Statistically, here's our numbers of the predicted data and the actual data, where the loss is very low. Also, we used the same model for Germany, which also gave a very confident score of the prediction compared to actual data. As you can see here, the numbers is typically very, very close. Also in the curve, if you are considering the y-axis as the time in days and the x-axis as the number of cases, The average loss for 3 days in Germany was calculated in the period of 28 June to 30 June 2020 and was estimated as 0.67%, which is a very, very low and not even close to 1% error. Also, we made the same criteria for the USA and also it gave an average loss for 3 days of 0.78%, which is totally not equal to 1%. Same for Italy, and here the mean error or the average error for 3 days was 0.42 using the same model in the same period. Since the live predictor was verified, we need to deploy this live predictor so that the user can use this live predictor, and also our main target, which is the country responsible, can use this live predictor. The live predictor was built in an API, and this API is called in the deployment stage. This paper later came under an application that was submitted to the Academy of Science Research Technology under the name of WHY. This application was introduced in Android and iOS solutions that contained our 3 modules of prediction, diagnosis, and awareness, and also contain some features, extra features in statistics worldwide. As you can see here, we can see our chatbot in Android and iOS, and also our chest X-ray. Thank you for watching our presentation.